Good morning, friends. In last lecture, we discussed about the reflection by a spherical surface. Now, and also in the beginning of this chapter, we discussed about the different type of the mirror. In this chapter, we are also going to learn about the lenses and also what is the reflection take place by the lenses. In our NCERT textbook, directly the reflection by the lens is given, but no any definition of the lens or how many principal focus, how many focal length, how many radius of curvature are not given. So for that purpose, we first take the introduction about the lens and how many type of the lenses are available, and also what are the basic term or the some points we have to know. Okay. Now, for that purpose, lens is generally lens is the transparent medium having the two bounded surface, spherical surface. Generally, we know this thing. Actually, the lens is the image forming device. Image forming device having two surfaces with the two bounded reflecting surfaces. At least out of these two, at least the one surface must be covered. One surface must be covered. And due to that reason, here the types of the mirror are generally five types. First thing, what is the definition of the lens? For that purpose, lens is an image forming device. Having two bounded reflecting surfaces out of these two surfaces, out of these two surfaces, at least one is curved or spherical. Curved or spherical. So there is a concept of the lens. Here there is the image forming device. Here the two bounded surface. This surface must be reflecting. That means the reflection takes place at both surfaces. Out of these two surfaces, at least the one must be cut. One must be cut. Okay. Now the types of the lenses. Suppose the both surfaces are curved. So that is known as the bioconvex lens. Bioconvex, or that is also known as only convex lens. After that, one surface is plane, second is spherical, this manner. So there is the plano-convex lens. Plano-convex lens. After that, suppose the both surfaces are curved like this manner, same side curvature. So there is the convex lens with meniscus. There is the convex lens with meniscus. After that, one more type of this lens is that both surfaces are this. So there is the bioconcave lens or concave lens. Concave lens. After that, one more type of the lens. That is plano-convex lens. Plano-concave On the base of this surfaces, on the base of the surfaces, we give the name of type of the lenses. So generally this type of the lenses, there is the convex, simple convex lens we are using in experiment. There is the plano convex, because the out of these two affecting surfaces, one is the plane. So that is known as the plano convex lens. There is the convex lens with meniscus. Here the both surfaces are spherical in the same direction. But here the medium is bounded by these two surfaces, so this acts as the lens. Here the bioconcave, here the both spherical surfaces this manner. So bioconcave or the only concave lens. And here there is the plano concave lens. Okay. Now there are some important terms. What are the principal focus? Principal focus of the lens. In case of the mirror, we already know that the mirror has the single principal focus, therefore it has the single radius of curvature and also the focal length. But here now listen, in a convex lens, suppose we consider a convex lens, so this surface is like this manner, and corresponding to this surface, so the two spheres we obtain according to a definition of center of curvature. The center of curvature, that means the center of a spherical cell from which this lens is cut. So there is the one C. There is for surface second, there is the one, therefore there is the C. For surface one, center is this, so there is the C. Now, the geometric center of this lens is this. Actually, in case of our mirror, there is the pole, but here there is the optical center. There is the optical center. That is denoted by O or C. O or C. Now, this distance OC1, there is a radius of curvature for this convex lens. And this distance OC2 is also the radius of curvature for second surface. That means it has the two radius of curvature, I1 and I2. Here the sign convention is also used according to the direction of incident light. Generally, the I1 is positive, I2 is negative, because the light is only always incident from the surface one. Okay. Now, it has the two center of curvature, therefore it must have the two principal focus. What are the definition of first principal focus and second principal focus of a lens in case of a convex and concave lens? For that purpose, we first do the diagram and then define the principal focus. For that purpose, what is the definition of first principal focus? That is denoted as F1. That is denoted as F1. For that purpose here, we consider the convex lens. If the point-like object is placed on the principal focus, is placed on a principal axis at any point, there is an object in such a way that the ray from this object incident on a lens and after the reflection becomes the parallel to the principal axis. So this point or the position of an object is known as first principal focus. Again, if point object is placed on the principal axis of a convex lens. The refracted becomes parallel. Such position of a point object is known as principal focus. There is a point, that means there is the first principal focus in case of a convex lens. Again, if the point object is placed any point on principal focus in such a way that the rays after the reflection by the lens becomes parallel to the principal axis, in that case the position of this object is known as the first principal focus. Now the second principal focus. Second principal focus. That is our active. In that case, what is the definition of the second principal focus? Here, the point object is placed on a point on the principal axis, so effectively becomes the pair. Yes, we think that the object is at infinite distance, so opposite to that, the rays coming from the infinite distance object are parallel to the principal axis. After the reflection, meet at a point on the principal axis. This point is known as the second principal focus. Like this way, the rays coming from the far object, where the object is placed at infinite. After the reflection, all the rays meet the point that is known as the second principal focus. For that purpose, the object is at infinite. The rays after the reflection are meet in case of a convex lens, or appear to meet in case of a concave lens. Such point is known as second principal focus. That is the F. Again, if object is an infinite, the rays coming from this are the parallel. After the reflection are meet in case of a convex lens, or appear to meet in case of a concave lens. Such point is known as the second principal focus. Now, in case of the concave, there is the principal axis. The rays are incident on a concave mirror are parallel because the object is at infinite distance. After the reflection, these rays are meet at this point. So that is the second principal focus in case of a concave lens. Right? Okay. Now one more thing. For convex lens, the focal length is positive. Concave lens, focal length is always negative. For convex, F is positive, and for concave, F is negative. So when we are using the sign convention for the focal length for convex and concave, always keep in mind that for convex lens F is positive, for concave F is negative always. Clear this thing? Okay. So these are the important points for in case of a lens that is not given in our textbook. What is the definition of the lens and also which are the different type of the lenses. And lens has the two areas of curvature and also the two principal focus. Generally, most of the lenses, the areas of curvature are same, but there is not compulsory. Areas of curvature are same. Sometimes there is also different. Clear this thing? Okay. When we discuss about the numerical, at the time concept becomes the more clear for lens. Clear? Okay. Okay, now after the introduction about the lens, now we complete some illustration and numerical exercise on the base of the shift of a sun and also on the base of the reflection by the spherical surface and also on the base of the total internal reflection. Now here the illustration 9.5 is given like that way. The Earth, we know that the Earth rotates about its one axis in how much time? 24 hours. That means the Earth takes the time 24 hours for 366. If the sun is observing from the surface of the Earth, so calculate the time for the shift of the sun of 1 degree. That means the Earth in 24 hours complete Earth rotate about its one axis. Rotate about its one axis. So 360 degree shift for the rotation of the Earth take place in 24 hours. Yes, we are observing the sun from the surface of the Earth. So Earth is rotating, therefore surface of the Earth is seen. So when the surface of the Earth is taking place here, therefore the shift of the sun is 1 degree. So how is that taken by the sun for the shift of 1 degree? Where is it? For 360 shift or displacement. The time taken is T is equal to 24 hours into 60 minutes. Therefore, time for shift or displacement of 1 degree is equal to, therefore, 24 into 60 into 1 degree divided by 360. Divided by 360. Therefore, there is the 4 minutes. So 4 minutes is the time for the shift of the sun by 1 degree. Again, already we discussed about this. The sun set or the sun rises on the 2 minutes earlier or the 2 minutes later after the actual time of the sunrise and sunset. Right? At that time, the shift is the half degree. Here the shift is what? 1 degree. For half degree, time is 2 minutes. Here the 1 degree, time is 4 minutes. Now, next illustration 9.6. The rays fall on a spherical surface having the refractive index 1.5 and radius of curvature is 20 centimeter in aluminium. Therefore, the refractive index for spherical surface, refractive index n is equal to 1.5. Radius of curvature R is given to 20 centimeter, convert into meter, therefore 0.2 meter. The object is placed at 100 centimeter distance from the spherical surface, therefore the object distance U is equal to minus 100 centimeter with the sign convention. Find the position of the image. That means we have to find out the image distance V is equal to 1. Here the figure is not necessary for this numerical, but we can do for a clear concept. So there is the spherical surface. Here the point-like object O is placed at 100 centimeter distance. There is a minus U. There is pole P. Here the effective index of this medium is 1.5 and radius of curvature this C point. That is the R. R is given the 20 centimeter. The ray incident on the point N1 after the reflection, that is meet the principal axis here. So that is the image is formed at this point. That is our image distance. So how we can calculate it? So here there is the A medium and there is the given medium glass medium 1.5. So ray of the light is starting from A, that means the ray to the denser medium. Therefore, from reflection by a spherical surface, we are using this equation minus N1 upon U plus N2 upon V is equal to N2 minus N1 upon V. Here N1 for A medium there is 1. N2 given medium, that means the glass here given, there is the 1.5. U is equal to minus 100 centimeter, that means the minus 1 meter. Substitute the value, therefore minus N1 1 upon minus 100 plus 100, that means the 1 meter. Here N2 is 1.5, here V is equal to 1.5 minus 1 upon 0.5. So by simplifying this equation, so we obtain the V is also 100 centimeter. That means the position of the image is obtained at 100 centimeter. Clear the same? So very easy numerical, only the use of the equation, only we obtain this equation from the reflection by a spherical curve surface. Clear this? Now the example 9.4 of exercise. Here for A glass interface and A water interface, the light is incident at 60 degrees and respective the angle of reflection are given. Okay. Now for glass water interface, for the water glass interface, if the angle of incidence is 45 degrees, fine. The angle of reflection for water and glass interface. Here these three figures are given, figure A, figure B and figure C. Again, for A glass and A water interface, the angle of incidence and respective angle of reflection are given. Now, effective indices of the glass and water and A medium are given. Clear? Now, for the water glass interface, the ray of the light is entered from water to the glass. Here, the angle of incidence is given 45 degrees and the angle of reflection. So, here we are using the Snell's law. So n1 sin I is equal to n2 sin R. Or in other words, sin R upon sin R, sin I upon sin R is equal to n2 upon n1. So here there is a first medium for figure A, there is a second medium. For figure A, from Snell's law, sin I upon sin R is equal to n2 upon n1. Here that is the n2 is equal to the index of a glass. Here n1 is equal to n A medium, n. Therefore n2 upon n1, that means the ng upon na. Therefore ng upon na is equal to sin I. Sin I is equal to 60 degree upon sin R 35. Sin 60 in natural sine table. So there is a 0.8660. And sin 35 from the natural sine table, there is a 0.5736. 0.5736. So its simplification is the 1.51. 1.5. Actually, that is the defect index of the glass medium with respect to the A medium. So there is the ng upon na. There is question number. Now for figure B. For figure, again there is a medium 1. A medium is 1 because the A coming in entering from medium 1 and enter the medium 2. So here n1 is equal to na is equal to 1. Here now listen. Water is our second medium, n2 is equal to nw. Therefore, the sin I upon sin R is equal to n2 upon na. That means the nw upon na. Therefore, nw upon na is equal to. What's upon? That means the effective index of water with respect to the air is equal to sin. I is given the 60 degree upon sin 47. Sin 60, already we know that 0.8660 upon sin 47, 0.6561, 0.6561. Therefore, there is the 1.32. There is the effective index of water with respect to the air. That is your second equation. Now for figure C. For figure C. Here instead of the water, instead of the air, here the water and glass two mediums are given. Therefore, here the incident air enter from water medium, so there is a medium 1. So its effective index involved is equal to nw. And reflected in second medium, so there is second medium, there is the glass medium. Therefore, n2 is equal to ng. Now, how we can write down this? Therefore, from Snell's law, sin I upon sin R is equal to n2 upon n. n2 is ng. ng upon nw. So, the right hand side of this equation is divided by na. ng upon na, here nw upon n. Now, ng upon na, there is a value of equation 1, and nw upon na, there is a equation 2. Therefore, sin I upon sin R is equal to ng upon na, 1.51. That is the 1.32. What we require? We require the sin R is equal to sin I into 1.32 upon 1.51. Sin I is 45. sine 45 into 1.32 1.51. Sine 45.7071 into 1.32 upon 1.51. So thus we obtain the value of R is equal to 38.2 degrees. So that is the angle of deflection in whatever medium, water and glass, or interface with the water and glass. Okay. So very easy, only from the scales law we can calculate the angle of deflection on the base of the earlier two different interfaces, air glass, water air, and then